Yes, hello members. We are on the topic called curve sketching, and in here I'm going to be able to show you steps we need to do for such a topic. Right away I'm going to give you about 4 steps we need to do, and normally this number is brought in section B. So what we are going to do, the first step for us to we have to get the x-intercept. This is where the curve meets the x-axis. So I'll start by saying, if I would call it part A, I have to find the x-intercept. This is where y is equal to 0. So I have this equation, y equals to negative x squared plus 2x plus 3. If I equate this expression to 0, I have to be able to get something which is just similar, x minus 3 into x plus 1, of which my x will be positive 3 and also negative 1. I don't have to go through too much for you to be able to get these answers, but those who know, you know how I have arrived to that point. So the curve meets the x-axis at these points, whereby x is this and also x is this. But if I try to put these values from the original equation, I have to be able to get the corresponding y's. So if I put x to be 3, my y will be 0. And also if I put my x as negative 1, my y also will be 0. If I try to put these values in the original equation. So the curve meets the x-axis at these points at 3, 0 and negative 1, 0. So that's the first step I've done. The second one, let me call it part B. I have to find the y-intercept. Now the y-intercept, this is where x equals to 0. Now, having our original equation plus 3, putting my x as 0, my y will just be a positive 3. So in here the coordinate I will have 0, 3. So this is where the curve meets the y-axis. The y-axis. So having that point, I'll look for what I will call part C, the turning points. Now in here, if I have my original plus 2x plus 3, I will first differentiate it, what we call the y dx. The y dx will give me negative 2x, I hope we are together, plus 2. So this is my dy dx. After getting my dy dx, I have to get the value of x, of which my dy dx is 0. That would be my turning point. So in here I'm getting the turning point. part C. If I equate 0 to what I have here, I'll get my x as 1 in 1. So putting this value into the original expression, I'll be able to get as my y putting x as 1, I'll be able to get my y as 6. So my turning point is 1, 6. So that's my turning point. So far we have 3 steps which I've worked on right now. Those are 3 steps. First find the x-intercept, y-intercept, then find the turning point, or stationary points for that case, that's part C. And now I'm going to determine the nature of the curve, and then I draw it and we see what to do. So part D is nature of the curve, the nature of the curve. So in here I will have value of x, then the sine of dy dx. I'll have a kind of a table which I'm going to use to help us in this issue. So in here I will have my left, I'll have this value which I've got at the differentiation, the value of x, which is 1. I've got only 1, and I will have the right. So I'm going to choose a number, those who know integers, or a number line. The left value to 1 is 0, the immediate one. So if I try to put 0 in here at dy dx as x being 0, I'll be able to get a positive value. You all see that. And if I try to put 1 from the dy dx, I'll be able to get 0. And if I try to pick a number on the right of 1 on the number line, let me take the immediate one, which is 2. If I try to put here 2, I'll get negative 4 plus 2. I'll still get a negative value. So the nature of the curve, since this one is a positive, it means the slope is going up, or a positive slope. The 0 means something like this, and then the negative means it is sloping down. So in here I have something like a maximum slope. I hope you are following. So this is the nature of the curve I have, and I'm going to try to draw it. Let me use this side. I'm going to try to draw the curve, just a sketchy diagram, just to show you how this could be. Let me use this space, I think it will be enough. Supposing I have a number line, just simple one, and this is my 0 mark. I'll call this part A, B, C, D, E, part E, sketching. If I take to be my 0, this point, this is 1, this is 2, this is 3, this is negative 1, negative 2, this is 1, this is 2, this is 3 negatives. I hope you are following. This is 1, this is 2, This is 3. This is the y-axis. This is the x-axis. And I'm trying to draw the curve which is required. But remember, we have from the very beginning the values where the curve meets the x-axis. I have 3, 0, 3, 0, and that point is just here, 3, 0. And also I have negative 1, 0, negative 1, 0. So that's the point. I already have 2 points where the curve meets the x-axis. Where the curve meets the y-axis, I hope you could see where the curve meets the y-axis. The y-axis is here, what we call the y-intercept. I have this point 0, 3, 0, then 3. So I already have even my curve. So the curve will come like this, passing through that point. It will cross that, then it will find its way like this. So this is my curve. This is my curve. And supposing maybe they want you to find the area enclosed by the curve, just in case. So I have part A, B, C, D, E. Let me call this one F. Just this one is just a by the way. It's not a requirement in curve sketching. The curve sketching number for it has ended in here. We have all these steps. Find the